with number 3. Right off the bat, we got to ask ourselves the question, is this a big number or a small number? Number 3, is that large or small? Small. How do we know that it's small? Because all those zeros are in the front. It starts with 0. This is very, very small, right? It's a decimal number. So we know that my exponent is going to be what? Negative. Got to keep that in mind, because it's going to change our answer dramatically. We see where our decimal is at. It's right there. But where do we want it to end up? All the way on the right? Yeah? Between the 7 and the 6. We want our new leading number in front to be 7.6, because that number is in between 1 and 10. If we brought that decimal all the way to the right, we'd have 76, right? And that's not in between 1 and 10, so we don't want that. We'll count our spaces. 1, 2, 3, 4 spaces. So there is my answer, right? What's wrong with it? That's right. My exponent here should be negative because, again, we've got a small number. Small number, negative exponent, always. Anybody get 7.6 times 10 to the negative 4th? Does that look good? Good, okay. Down to 8. Now this is a super duper small number. There's a bunch of zeros in the front, so we know we're going to have a negative exponent here as well. Where do I want my decimal point to end up in number 8? Between the 4 and the 3. So let's count it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces to the right. Gives me 4.3 times 10 to the negative 12. Make sure you are being very careful when you're counting, because if this question shows up on the final, your answer choices are going to be 4.3 times 10 to the negative 12th, 4.3 times 10 to the negative 11th, and 4.3 times 10 to the negative 13th. So as long as you're counting correctly, you should be good to go. But if you mess up one little space or count one space twice, you're going to get the wrong answer. Questions about converting from standard to scientific? Okay, let's flip it around. Let's go scientific to standard, starting with number 11. Is this going to be a large number or a small number? What sign is my exponent? Positive, so this is a large number. All right, I'm going to rewrite 7.0, and I'm going to move that decimal how many spaces? 3. To the left or to the right? To the right. We want those zeros to be on the end to get a large number. And we end up with 7,000. 7,000. Don't just leave your answer like this on this worksheet. Make sure you write it nice and cleanly so that I can see exactly what number we're talking about. Okay, I don't want to see 2 decimals in there if our answer is 7,000. Down to 15, 8.946 times 10 to the 10th. Large or small for this one? Way large. It's a big old positive exponent there. 8.946. We're going to move that decimal to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. 1, 2, 3, 4, 5, 6, 7 zeros. 8, 9, 4, 6. 1, 2, 3, 4, 5, 6, 7. Now with our commas, we want to count from right to left. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. What number is that? 89,460,000,000. Super, super large number, we can tell because the exponent is positive. And we move 10 spaces to match that 10 on our power. This is our answer. You want to know what's not our answer? What am I missing in this number here? The 4 and the 6. Not why I'm missing the box, but I'm missing the 4 and the 6. Right? Something we need to keep in mind with this is every single number has to be included in your answer. If you just drop the 4 and the 6, that is incorrect. That is not the same number. Right? And you may be like, well, what's the big difference? It's a difference of 460 million. That would be the difference. Right? It's not just a little 4 and a little 6. In this particular context, you'd be leaving out 460 million. If you're talking about money, it's quite a big difference there. Any final questions going from scientific to standard? But again, on the final, this is going to be an answer choice. Right? You may move the decimal the right number of spaces, but if you forget to keep all those numbers in there, you might end up getting the wrong answer. Flipping over to the back, number 20. If I want to find K, what's my formula for K? K is equal to what? Y over X. Remember, Y, aren't you, over your X? Okay? So I'm going to take my first point. 5 is my Y. 10 is my X. And what does 5 over 10 simplify to? 2 is very close. There is going to be a 2, but it's on the bottom. We end up with 1/2, right? 5 out of 10, right? If you shoot if you make 5 shots out of the 10 that you shoot, you've made half the shots, right? That's good. If you shoot 50%, it's considered good. You know, grade-wise, that'd be an F, but we're talking about basketball. It's good. Then make sure you did this second part. Write the equation in the form y is equal to kx, where we replace that k with the k that we found. If k is 1/2, my equation will be y is equal to 1/2 x. So you should have 2 answers circled for those 6 on the back. The k value and the actual equation. Last but not least, 23, finding k from a graph. We could do rise over run, or we could just pick a point, any point. Take a look at the x coordinate. Where's my x coordinate for that point? 6. Where's my y coordinate? 4. Y over x gives me 4 over 6. How can we simplify 4 over 6? Well, let's break it up. 4 is 2 times 2. 6 is 2 times 3. What can we cancel? Pair of 2's. And we're left with 2 over 3. That's my value for k. Does this graph show a straight line? Everybody, does this graph show me a straight line? Yeah. Yes, absolutely. Is this graph going through the origin? Thank you.
Yeah.
Yes, it is. The origin is right there at 0, 0. Both of those conditions are met. So what type of relationship is this? Proportional. It's a proportional relationship because it is a straight line through the origin. If we have a straight line that doesn't go through the origin, what type of relationship is that? Non-proportional. Exactly. Great job. I appreciate you guys' help with that.